Okay, welcome back, everyone. All right, now we're going to actually start the trigonometry part of the unit that we're going to spend this week and next week on. And hopefully on your screen you're looking at a triangle, a bluish triangle, and it's marked ABC, and it's a right triangle, and I know it's a right triangle because I can see the right angle mark in the corner there, so that tells me it's 90 degrees. A couple things you may notice about this triangle that you may not have before. One is that the symbol down here is maybe an unusual symbol. Maybe you've seen it, maybe not. It's a Greek symbol, and it's a Greek letter actually. The letter is theta, and trigonometry uses Greek letters to identify angles. This angle could be called angle A, and there's nothing wrong with calling this angle A. But we could also use a Greek letter, and we just insert it right there in the vertex, and we can call this angle theta. And there's other letters like alpha and beta that are used commonly in trigonometry. So this will be your introduction. We're just so you don't get confused. The symbol is a Greek letter. It's no different than using X, Y, or Z. All right. So if you look at your screen there, what you're looking at is a simple right triangle. And just as a refresher, if you look at the right angle, right across from the right angle is the longest side of the triangle, and we call that the hypotenuse. And hypotenuses only exist in right triangle. There's no such thing as a hypotenuse in an obtuse triangle, for example. So you need the right angle to create a hypotenuse. And that's where we start our investigation of trigonometry. The reason we start with right triangles is because right triangles are very easy to create. You know, they're part of rectangles, they're part of squares, but even if you just had 2 points, 2 random points on the screen, you could easily create a right triangle out of it by connecting the dots, and then you would just do and then after 2 points, you would just make the right angle out of it just by dropping a vertical line. You can just go straight down. You make the vertical line, right? And then you can go make a 90 degrees straight across. And you can easily get a right triangle out of it doing that. So even if you just have 2 points, it's very simple to create the right triangle. So that's why we begin our investigation with right triangles. Okay, so let me just get rid of that triangle. I just want to show you the creation of the right triangle. Now let's get back to the trigonometry and where these fractions come from that you're looking at on the screen. I know they might look a little confusing. It's pretty straightforward. You have a right triangle, and there's 3 angles, of course, and you have the hypotenuse that I mentioned, the right angle. And I'm going to focus my attention right here on this symbol, this theta symbol, angle A. And because a triangle has 3 sides, all trigonometry is a relationship between 2 of the sides. So if you remember your work from probability, if you have 3 sides, you can make a total of 6 combinations, taking 2 at a time. And so there's a total of 6 ways to arrange the 2 sides. On the screen, we're going to do the first 3, and then in the next one, we'll do the last 3. So there's 6 total ways to arrange the 2 sides. So you might say trigonometry is just an arbitrary arrangement of the sides. And we give names to each relationship. And here we go. The first relationship is called the sine, S-I-N-E. It is often abbreviated S-I-N. Please don't call that sin. It's not the sin, it's the sine. And the way it works is we say the sine of theta, or the sine of angle A. So here's theta. It's a relationship. The relationship is the opposite side divided by the hypotenuse. And so if you follow theta across, the opposite side would be this one right here called CB or BC. So that's the side you want to look at. And what we do is we compare that side to the hypotenuse, the longest side of the right triangle. That's it. That's what the sine is. That's the definition of a sine. The definition of a sine is you have a right triangle, you look at one of the angles, the opposite side compared to the hypotenuse. And that's all there is to the definition. So that's one relationship. A second relationship is called the cosine. There's a CO in front of it. Now there's a reason why it's called cosine, why there's a CO in front of the sine, and I'll talk more about that later. Right now, for the cosine, that's a relationship between the adjacent side to the angle you're looking at and the hypotenuse. So again, find that theta, there it is. The adjacent side, that's a fancy word for saying next to, the side that's next to the angle. So you really have two sides that are next to the angle. You have this one called AC, right? You have this AC, or you have the other one right next to it, AB. So which one is the adjacent side? Well, because the longest side, the AB side, already has a name. It has a hypotenuse. That's called a hypotenuse of the longest side of the right triangle. We don't consider that the adjacent side. We only consider the other one, the one that's not the hypotenuse, the leg of the triangle, as the adjacent side. So we take the adjacent side, the one next to the angle that's not the hypotenuse, and we divide it by the hypotenuse. That's it. That's a definition of cosine. And the last comparison we make, the primary, these are called primary trig ratios, is called the tangent. The tangent of theta is the opposite side over here. So you find theta again. So we're looking at theta. The opposite side, CB, is being compared to the adjacent side. Now again, the adjacent side can't be the hypotenuse, so it's got to be the one across from it divided by, in this problem it would be CB divided by AC. So the opposite side divided by the adjacent side. And believe it or not, all this is really going to be powerful stuff later on when you see the word problems that you have to solve. You really can solve some incredibly long distances using these relationships by using similar triangles. So this might be a little daunting. These are all, all three ratios are being thrown at you. Over the years, there's been ways to try to remember these, because the reality is you're going to have to memorize these eventually. You're going to have to know what they are inside and out without thinking. So it is difficult sometimes to try to remember what sides match up. So we have a little acronym, and that acronym is Sohcahtoa. You probably want to pause the video here to write this down. And let me explain what Sohcahtoa stands for. Sohcahtoa, the Indian chief Sohcahtoa. Many math teachers have used this. It's a way to memorize or remember what the three ratios are. Sohcahtoa, S-O-H. The S stands for sine. The O is the opposite side. The H is the hypotenuse. So the sine equals the opposite over the hypotenuse. Koa, the cosine equals the adjacent over the hypotenuse. And toa, the tangent equals the opposite side divided by the adjacent side. So it's a nice way to remember all three ratios. I would certainly write them down, and I would put a little legend for what each letter stands for, so that's really what you want to keep in your mind, the Sohcahtoa. So go ahead and pause the video here. Make sure you get that in your notes, and when you're ready, come on back. Okay, now that you have it in your notebook, I said there were 6 altogether. So on the screen, you're only looking at 3 of them. So there must be 3 more. Again, there's 3 sides. So the probability, the combinations that you would get would be 3 sides taken 2 at a time. You would get 3 times 2 times 1, or 3 factorial. 3 factorial equals 3 times 2 is 6, times 1 is 6. There's 6 total ways of arranging 2 sides. So there's 3 of them. So the other 3 are actually, just based on the first 3. And here's another screen for that. So here are all 6 ratios. There are no other ones. There's only 6, because there's only 6 total combinations. So again, pause the video here. Get all 6 of these in your notebook so you have them available. All right, let's go through these. In the last screen, Sohcahtoa, we saw that the sine is the opposite over the hypotenuse. Well, if you take the reciprocal of that, if you just take the fraction and you flip it upside down, the reciprocal, you'll get what's called the cosecant. So the cosecant is the reciprocal of the sine. It's the answer, whatever the sine is, whatever the answer that is, the ratio, you take that and you take the reciprocal, and that's how you get the cosecant. And that's defined as the hypotenuse divided by the opposite side. Hypotenuse divided by the opposite side. Okay, same thing holds true for the next one. The next one is called the secant. The secant. Now, obviously the secant and the cosecant are related somehow. There's got that CO in front of it again. We'll talk about that in a different video. Right now, I just want you to focus in on the cosine is the adjacent side divided by the hypotenuse. The reciprocal of that would be the hypotenuse divided by the adjacent side. We call that the secant, the secant. And finally, the last one is called the cotangent. It is the reciprocal of the tangent. So the tangent is the opposite side divided by the adjacent side. That's the toa in Sohcahtoa. And then cotangent would just take that and flip it upside down to get the reciprocal, adjacent over opposite. And the nice thing is about these are called the reciprocal ratios simply because you take the reciprocal of the principal ratios, the first three we talked about. The really nice thing about this is you don't have to memorize all six. You really just have to memorize the first three. Because if you know the first three, then all you have to do is take those answers and take the reciprocal to get the other three. The hardest part about the reciprocal ratios is remembering which ones line up. You have to remember that the cosecant is a reciprocal to sine, the secant is a reciprocal to cosine, and the tangent is a reciprocal to tangent. That's probably the hardest part of the reciprocal ratios. So I know there's a lot being thrown at you at this point. There's a lot of ratios here, but we're going to end the video here. In the next video, this really has a big impact on solving problems. So I want to show you two examples of how you would apply this so you can start to get a feel for where we're going with this. Algebra 2 is just an introduction to trigonometry. You're really going to spend an entire year on this stuff when you take a course. Trigonometry and statistics is usually taught together. Or if you take a pre-calculus course, that's where you pick up the trigonometry in a lot of detail. So in this course, all we try to do is give you the basics. So that's what we're going to go through. So the next video will cover a couple examples. You'll see why these are so important and why they're important enough to memorize and why Sohcahtoa exists, and you want to try to pick those up. All right, so I'll talk to you in the next video.